Hi everybody, this is Ms. Daly and I'm going to show you how to find some of these compound probabilities that you've been working on without an area model. Keep in mind that an area model will still work. However, if you're looking for kind of a shortcut, this might be a good option. Okay, let's look at the first one. We have ourselves a dice. Now, this problem as it's set up means the probability of getting 3 sixes in a row. So what I hope you've been finding is that there is a relationship between multiplication and finding the probability of multiple events happening in a row. So what we do is we take the probability of the first event, which is a 1 out of 6 chance that you'll get a 6 on your first roll, multiply by the event on the second, which is still 1 out of 6, and the third, which is still 1 out of 6. We multiply those together, 1 times 1 times 1 on the top, and 6 times 6 times 6 on the bottom. So there is a 1 out of 216 chance of getting 3 sixes in a row when you roll a dice 3 times. Okay, let's look at it as the map problem. So this problem here means what is the probability of starting over here and ending up at either this yellow star or this yellow star. So we're going to find the probability of those separately and then add them together. So for the top star, if we were coming out of the starting place, there's a 1/3 chance that we'll end up on a path to get us to that star. So we start with 1/3. Then there is a 1/3 chance at this juncture that we'll end up heading towards the star and getting there. So we multiply by 1/3 again. This means that there is a 1 in 9 chance of getting to that top star while randomly making choices through this maze. Okay, now let's focus on the bottom star, this guy here. So starting back here, there's a 1/3 chance that you'll be on the right path to reach that bottom star. So for the bottom, we start with 1/3. Then we reach this point here, and there's only a 1/2 chance that we're going to end up going the correct direction. So we multiply by 1/2. 1/3 times 1/2 makes 1/6. Now, since I want the total probability, I need to add those two together. So for my total probability, I will add 1/9 to 1/6. While doing that, I have to change them to have a common denominator. 9 and 6 both can change into 36. 1/9 is the same as 4/36. 1/6 is the same as 6/36. So that gives us 10 in 36 chance that we'll reach one of the stars. Simplified, that would give us 5 out of 18. All right, let's look at the last problem here. So if we're bowling and we're a very good bowler, there might be a 60% chance that we get a strike. That means we knock down all the pins on our first try. Now, if we don't knock down all of the pins on our first try, let's say we then have a 50% chance that we'll get a spare, which means that we take 2 turns to knock down all of the pins. So, if I'm interested in the probability of getting a spare, that means I had to not get a strike to start with. So, if the chance of getting a strike was 60%, that means the chance of not getting a strike on our very first roll would be 40%, or 4 out of 10. Okay, then we have our spare. So on our second turn, because we did not get a strike to start with, we are shooting for a spare. And there's a 50% chance of getting a spare on our second turn. So we multiply by 5 out of 10, which is equivalent to 50%. When we multiply those together, we get ourselves 20 out of 100, meaning there is a 20% chance that we'll get a strike or a spare in 2 rolls of our bowling. Okay, good luck, and don't forget to ask lots of questions in either the Google Meet, the Google Chats on Friday, or send a message through Google Classroom. Bye!